Okay, so I'm here trying to draw the metaphysis for you so you understand where it is and what's happening in the metaphysis. So it's a transitional zone between the cartilaginous head of a long bone and the shaft of a long bone, and it's really well defined at birth. So let's draw that. So I'm going to draw the shaft. The metaphysis would be here. There's the head, and there's another metaphysis region over here. All right. So in blue, we have cartilage. And in black, we have bone. So in the cartilage, this is something you already know. It's called the epiphysis. And in black, we call that the diaphysis. Now, remember, the shaft of a long bone is not solid. It actually has a rough surface and an opening in the middle. So this is a rough inner surface, and the opening in the middle is the medullary cavity. Medullary cavity. All right. So in the medullary cavity, this is where you have bone marrow, and it has cells in it, a lot of stem cells and osteogenic cells, etc. So that's in there. Let's go back to the epiphysis and the metaphysis. So here it is. The metaphysis is at this transition zone between the heads of the long bone and the shaft, also called the diaphysis of the long bone. So the metaphysis is actually made of several layers. Zone 1 through Zone 5. Zone 1, Zone 2, Zone 3, Zone 4, Zone 5. There are different cells layered on top of each other, and there's something happening in each of these layers. And basically, this story that's going on in the metaphysis, it's what's happening to transform the cartilage that we have so if we're looking at this metaphysis on the top here, so above, the cartilage from above transforms into bone and produces bone, and the bone is deposited here below. And as it's deposited, more bone is being produced, and more bone is being produced, etc., etc. And that's how we have bone growth in length. So in my next slide, I'm going to show you what's going on exactly in that metaphysis, what are each cell called in the zone 1 to zone 5 of these different layers, and what's going on. So I'm going to go to another slide to draw these zones one after the other. So we won't see the long bone anymore, but now we're going to talk just about the zones. And I will continue using blue for cartilage, and I'll use black for bone. So let's talk about these different zones. So zone 1 is also called zone of reserve cartilage. So zone 1, also called reserve cartilage. Or it's also called the resting zone. This is where you have regular hyaline cartilage cells that are in their lacunae, and usually these lacunae are found in pairs, sometimes by themselves, but it's usually in pairs. There we go. lots of blue glassy matrix, very pretty hyaline cartilage, regular. It looks like a normal hyaline cartilage. So that's reserve cartilage. This is our reserve of hyaline cartilage that looks normal. Then we have below that, we have zone 2. In zone 2, it's called zone of cell proliferation. So cell proliferation. What that means is that the cells are dividing and increasing in number. But two things are happening in that zone of proliferation. We have not only multiplication of cells, but we also have cells stacking up on top of each other. So now the lacunae are arranging in columns. So cells multiply and arrange in column. So I'm going to draw columns of cells over here. So remember, multiplication of cells and the lining up into columns. Two things are happening. Proliferation, which is a number of cells increasing, and also lining up into columns. Zone 3, it's called zone of hypertrophy or hypertrophic zone. This is where the cells enlarge and the lacunae enlarge. So hypertrophy is going on here. Hypertrophy. Hyper is bigger, larger. Troph is growth. So zone of hypertrophy, you have growth in size. The cells are enlarging. So think about the word enlargement. So here we go. Now we have really large lacunae. And as these cells enlarge and the lacunae are pushed out, you also have, as a consequence of that, you have a thinning of the matrix. You see the matrix that's in between here? Now it's getting thinner right here. So cells enlarge. So they're not arranging into columns here. They're already in columns. Here, all they're doing is enlarging. So the cells are enlarging. So there is no room for me here, but you should write underneath here, if you reproduce that diagram, which I suggest, you write here, cells are multiplying and lining up into columns. And under here, you would write, cells are enlarging. Zone 4, it's zone of calcification. Calcification. So what's happening here, I'm going to use a different color. What's happening is that you have calcium phosphates, minerals, that are coming, diffusing into this tissue and depositing in this matrix. So now the matrix is really brittle. Well, it's hardening, first of all, and it's going to become brittle. So it's going to really break. So calcium deposits. Calcification is calcium deposit. That's what I want you to do here. Put a little arrow like I did here and write increased number of cells and cells lining up in columns. And here increases in size of the cells. So zone 4, you have calcium deposit, and you have this matrix that becomes calcified. So this is a calcified cartilage at this point. And the columns really become long channels. I'm going to use the eraser real quick here. So actually here we have these walls that just break up the walls break up here. Yeah, I'll just do one more to show you what I'm talking about, these long channels that I'm talking about. So now we have these long channels that are forming because of this calcification. I'll take the calcification a little bit higher up. So under the microscope, this region is going to really stain differently. This is basically, you can see where the limits are. All right, so we have a very brittle matrix here. We have long empty channels. Why are they empty? It's because the cells were dying. That's really what's happening. When the cells were going through hypertrophy, they were not feeling good, and then they end up dying. So I'm going to draw and go back to the here my. So at this point, the cells are kind of like not sure what's going on. They're like really confused. They have to line up, but they're really not very happy. And all of a sudden, when they hypertrophy, they're basically starting to die. And at this point over here, there are no more cells. No more cells in here, they're all dead. So what you end up having is you have these open, empty lacunae, and it's basically these channels that are empty ghost towns because the cells are gone. So let's talk about zone 5, because this is really cool what happens in zone 5. This is zone of bone deposition. Bone deposition. So how are we going to have bone deposition over here? It's going to happen because on the other end, right, on this side, if you remember where we are in the picture that I drew earlier, on this side, so I'm going to continue drawing these channels. I'm just going to do that. And let me erase that one real quick. So what's on the bottom side is the marrow. The marrow from below. The marrow from below is going to break the wall here and flood these empty channels above, and they're going to basically, like a hose, they're going to like really spray the surface of these walls with osteogenic cells that are going to lay down on the surface of the wall like that. See that? These are osteogenic cells that are coming from the marrow below. We're talking about the marrow below. And it's spraying all of these osteogenic cells. These are going to be osteoblasts. Osteoblasts are going to form bone tissue, and this will be your first layer of bone tissue produced. And there will be one layer, and then it will harden, and then there will be another layer, and then it will harden, and then another layer, and it will harden, etc. What do you think I'm drawing? In the end, what I'm drawing actually are these different concentric lamellae that are forming osteons. And here we go. This is how osteons are formed in these long channels. We have bone deposition. So bone deposition in red. Bone deposition in red. From the marrow below, bringing these osteoblasts. And we'll also have osteoclasts to remodel whatever is put down to make sure it looks like an osteon. And we have one lamella, then another lamella, and more spraying, and another lamella produced from these different layers. Isn't that cool? And that's exactly how we have bone formation produced on the bottom, and another layer is produced, and we end up with longer and longer and longer bones that way.